What's the science behind meter sticks? And Mr. Hawkins opens a bike shop. All that today and more on A Moment of Science. Actually, a lot of science and math that goes into making a meter stick, okay? What you see before you is a meter stick, I promise you. Lots of little lines, that's usually how you know, okay? And on the meter stick, there are tons of little lines, and they're there for a reason, okay? 1 meter consists of 100 centimeters, okay? It increases by tens on here. You can see 10, 20, 30, 40, okay? So on. And then you can see the ones that correspond to those as well. Then in each one, you can see multiple lines that indicate the millimeters that are in that line as well, okay? So millimeters and centimeters are both demonstrated on the meter stick, okay? Making up 1 meter. So that's not the only thing though, okay? Take into consideration when you go to the grocery store. Say you want some eggs. Okay, you go to the grocery store, you have to buy half a dozen eggs, a dozen eggs, doesn't matter, okay? But you get in 1 carton of eggs, either 12 eggs or 6 eggs, depending on what size you buy. If you get a carton of eggs, it's a dozen, that means you get 12, okay? 1 dozen is 12 eggs. Now, we use conversion factors like this in science all of the time. Okay, for instance, 1 meter is equal to 100 centimeters. That's a conversion factor. All right, and those vary depending on what we're measuring and how we measure that. But we do use something called dimensional analysis in chemistry class to make sure that we can actually analyze where those changes do occur, where we go from a centimeter to a meter, okay? So let's say that I wanted to open up a bike shop because I'm a giant entrepreneur. I want to start my own business and I want to make that cha-ching, you know what I'm saying? Getting paper. So I want to make money, okay? And I'm going to open up a bike shop doing this, all right? And we know that bicycles have 2 tires, right? Usually, all right? In order to be a bicycle, it has to have 2 tires. So I open up my bike shop and I do have my 2 tires, okay? I want to design myself a bicycle. So our conversion factor here could be that there are 2 tires per 1 bicycle. All right, but let's say that somebody was really nice to me, really generous, and gave me 100 bicycle tires, okay? Much like the ones that I just showed you. So if I wanted to do dimensional analysis on this, I would have to design one of these first, okay? And this is what we used to do dimensional analysis. It looks kind of like train tracks, but only 1 bar, okay? But we would write our 100 tires right here, okay? And we have to make sure that we can figure out how many bicycles we can construct using those 100 tires. Okay? So at the end, we want to make sure that we're in the units of bicycles. Okay? So we have to have some kind of factor that will allow us to go from tires to bicycles, which is just kind of tough, all right? You can't just magically make it work, all right? You have to have that conversion factor. Okay? Because we can't get bicycles if we're using 3 tires to make it, right? So we do have to have a conversion factor. So we know that there are 2 tires per every 1 bike, okay? All right, now this is important, okay? If you'll notice, the units here, tires, match the units down here. Okay, if that's not the case, this ain't gonna work, okay? The units have to match up because once they do, boom, boom, they're gone, all right? No mo'. So what you're left with is bicycles and bicycles. You're left in that unit. Okay? Now what you would have to do is multiply the tops, multiply the bottoms, and divide by the 2 of them. Okay? Now this can get more complicated. I'll show you here in a second. But if you have that 100 tires, you divide by the 2 tires that's over here. 100 times 1 is 100. 2 times nothing is 2. Okay? 1 technically, because there's nothing else that it has to multiply by, so 2. Okay, 100 divided by 2 would give you 50 bicycles that I could make from the 100 tires that I was gifted. Okay, now, if I already told you that there were 100 centimeters in 1 meter, okay? Now right here I have 1 meter, and I'm trying to figure out how many centimeters are in that. Again, there is a conversion factor for that. All right, we understand that in 1 meter, there are 100 centimeters, okay? Again, remember if you flip that, it won't work right, okay? These 2 units have to match up in order to get canceled out so you can get left in the right unit at the end, okay? 1 times 100 equals 100 centimeters, okay? That's how I would prove that to you. Now you can do this if you're converting between US and metric numbers, or you can do this when you're converting between different types of metric numbers. For instance, if you're going from millimeters all the way to kilometers, you can use dimensional analysis to do this. But you do have to have that conversion factor. Without it, it won't work, okay? It's very important. So make sure that you're aware of what's going on with dimensional analysis. We're going to be covering it more in class next time when you come. But until then, we'll see you next time on A Moment of Science.